Hey there everyone, I'm Ridhima from Saurav's Classes and we are in the part 2 series of solving the IIT JAM Maths 2023 question paper. So the first question to the second part is the following. So let an be a sequence of real numbers defined by an is equals to 1 if n is prime and minus 1 if n is not prime. So let us write down the sequence. Then when n is 1, it is not a prime number. When it is not a prime number, so it's minus 1. That is a1 is equals to minus 1. A2 means n is a prime number, then it is plus 1. A3 again 1 because 3 is a prime number. A4 not a prime number. A5 prime number. A6 not a prime number, and so on. So from this is very clear that this series is oscillatory. Neither convergent nor divergent, so not convergent. Let us check the options. Both AN and BN are convergent. AN is not convergent. AN is convergent, but BN is not convergent. AN is not convergent. AN is not convergent, but BN is convergent. So here we have one possibility. We will check both AN and BN are not convergent. So C and D both are possibilities. Let us, in order to understand, let us check Bn. So now Bn is equals to, how can I write the Bn series? It is defined by An by n. So Bn will be 1 by n if n is prime, and minus 1 by n if n is non-prime. Now, as we increase the number of n from 1 to infinity, I can clearly say that as n tends to infinity, Bn tends to 0. So there is a possibility of convergence. So Bn is convergent. That means it is very clear that option C is the correct answer. Means An is not convergent, but Bn is definitely convergent. Next question is, you're given limit a tends to 0 and integral 0 to a sine x squared dx by integral 0 to a log of x plus 1 whole square dx. Now here, if you note, since this is in a division form, and if we put a tends to 0, then we are going to get it in 0 by 0 form. So that means we can use the LP rule, and we have to take the following formula, that is we can write using derivative. So limit a tends to 0, here this will become sine a square, and derivative of a is 1 divided by this is your log of a plus 1 whole square, and again derivative of a is 1. Now if we put a is equals to 0, then again sine 0 is 0, and log of 0 plus 1 is 0. So again this is in the form 0 by 0. So again we have to take the derivative, that is limit a tends to 0. So here sine of a square, this will be cos a square, and into 2a by 2 into log of a plus 1 into 1 by 1 plus a, right? Now this 2 cancel, so limit a tends to 0, cos of a square into 1 plus a divided by, we also have another a here, so a into cos a square by 1 plus a by log of a plus 1. Okay. Now if you put the values of 0 here, so what do we get? See, first let us just put it like this, that is a by ln 1 plus a here into cos of a square into 1 plus a. Okay, now if you put a is equals to 0 here, this is 1 into 1, but this is again 0 by 0, so that means we will get this also in the form of 0 by 0. So that means we have to again integrate this. So that means the only problem in this part where 0 by 0, we get 0 by 0 is a by ln by a. So we are going to integrate this part within the limits a tends to 0. So that means we get limit a tends to 0. Now so let us solve it, and that will be 1 by 1 plus a. So that is limit a tends to 0, 1 plus a, that is 1 plus 0 is equals to 1. That is the answer. So the next question here is, we have to find the global minimum for the following function given. So let us first write down the function. Let us say fx is equals to, this will be x minus 1 plus x minus 2 whole square if the value of x is greater than or equal to 1, and 1 minus x plus x minus 2 whole square if the value is x less than 1, right? Now for fx is equals to, so this will be x minus 1 plus x square plus 4 minus 4x for x greater than equals to 1, and this is 1 minus x plus x square minus 4x plus 4, again 4x less than 1. So fx is equals to x square minus 3x minus 3 for x greater than equals to 1, and this is x square minus 5x plus 5 for x less than 1. So this can be written as x square minus 2 into 3 by 2x plus 3 by 2 whole square minus 3 by 2 whole square minus 3 for x greater than equals to 1. And this can be written as x square minus 2 into 5 by 2 into x plus 5 by 2 whole square minus 5 by 2 whole square plus 5 for x less than 1. So this can be written as f of x is equals to, this is x minus 3 by 2 whole square, and this is 9 by 4 minus 3, so minus 3 by 4 for x greater than equals to 1. And here it will be x minus 5 by 2 whole square, this is 25 by 4 plus 25, so the LCM of this will be minus 25 plus 20, so this is minus 5 by 4, and this shall be plus 3 by 4. So this is it. Now if we put this as y is equals to, so we have got these equations. For x greater than equals to 1 and x less than 1. So that means here we can write down y minus 3 by 4 is equals to x minus 3 by 2 whole square for x greater than equals to 1, and x minus 5 by 2 minus 5 by, sorry, this is y plus 5 by 4 is equals to x minus 5 by 2 whole square for x less than 1. So of course we are going to get a parabola, right? From this equation it is very clear. So let's draw. Okay, let's take this. Right. So this is x, say this is y, this is, if this is 0, 1, 2, 3. Now here it's clear that the coordinates will be, this one is 3 by 4. 3 by 4 means um, around 0.7, and this is 3 by 2 is 1.5. So we are talking about a point here. So this is 1, 2, 3. So somewhere here and here. So this is the coordinates here, right? Now, so a parabola here will look like what? This is for the 1 and greater than 1. That means I will start from this point. I will meet this point and I will go here because this is positive this side. So that will face this side. So this is the diagram for this one. And for x less than 1, this is for x less than 1. That means it will meet here. Let's use this color. And since there is with the negative coordinate and there is positivity, so it will face this side and it will meet here. So this part is for x less than 1, and this part is for x greater than equals to 1. Now for this, the minimum point is at the point here. It's very clear. So this point is our 3 by 4, and that is the answer. So the minimum global point is 3 by 4. So here we have to write the answer for the 2 decimal places. So 3 by 4 is 0 0.0, 3 7s are 28, so this is 2, so this is 5, so it is 0.75. Let us have a look at the next question. So here we are given 2 sequences AN and BN, right? And this is the condition given. Now let us try to find out for A and B separately whether it will converge or not, right? So let us take the series here. For AN, we can write this as the follows. AN plus 1 minus AN is equals to 1 by 2 to the power n. If we write down the values of n, suppose n is equals to 1, then this is A2 minus A1 is equals to 1 by 2. A3 minus A2 is equals to 1 by 2 square. A4 minus A3 is equals to 1 by 2 cube, and so on, such that this is AN minus A of n minus 1 is equals to 1 by 2 to the power n minus 1. A of n plus 1 minus A of n is equals to 1 by 2 to the power n. And then if we calculate it, so if we add this in order to form the series, we can easily see that A2 gets cancelled, A3 gets cancelled, so on A4 there will be some A4, AN gets cancelled, and AN1, and before this there should be AN1, so all these gets cancelled. Only number that is left is the first one and the last one, right? So what do we get? So this can be written as the summation of the series will become AN plus 1 minus A1 is equals to half plus 1 by square plus 1 by 2 cube plus dot 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 plus 1 by 2 to the power n. So AN plus 1 minus A1 is equals to, so this is our GP series. So this is what the first term, that is A, 1 plus R to the power n. What is the R? That is the common ratio, that is half. So this is to the power n whole to the power 1 minus R. So 1 minus half is half, so this gets cancelled. So this is 1 minus 1 by 2 to the power n. So that means from here we get AN1 minus A1 is equals to 2 to the power n minus 1 by 2 to the power n. Now this is AN plus 1 is equals to A1 plus 1 minus 1 by 2 to the power n. So here as n tends to infinity, obviously an plus 1 tends to converge. So that means series A is convergent. Now let us talk about series B. We are given bn plus 1 minus bn is equals to 1 by root n. Okay. Now for that, again we will go through the same procedure. So here we will actually get, so after putting the values and again cancelling out, we will get bn plus 1 minus bn is equals to basically 1 by root 1 plus 1 by root 2 plus 1 by root 3 plus dot 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 1 by root n. Now this is basically our, the summation is basically our 1 by n to the power half. This is very clear, as n tends to infinity, 1 by root n will tend to diverge. So the answer to this question is series A will converge and series B will diverge.